Hello and welcome to this video about potential difference. Potential difference is the same as voltage. You might have heard that before, but voltage is not the word that they use in your exam. They use the word potential difference in all of your questions. And on your datasheet you'll be given an equation which links potential difference with work done and charge. And where it says potential difference equals work done divided by charge. And this will help you remember what potential difference is. If they ask you for a definition of potential difference, which would be a quite tricky question, but if they did, I would refer you straight to your data sheet and you could try and use this equation to help you write down what the definition is. Because if we use this, we can see that potential difference is the work done per coulomb of charge. And hopefully if I ask you the question, what is work done the same as? What is work done the same as? Hopefully you'll remember that work done is the same thing as energy transferred. So you could say energy transferred per coulomb of charge. Remembering from a previous video that coulombs are the units for charge. So you can either think of it as the work done per coulomb of charge or the energy transferred per coulomb of charge, because these two things are the same thing. Again, they won't give you a unit, so you'll need to remember the potential difference is measured in volts, capital V, work done is measured in joules, and charge is measured in coulombs. For potential difference then, you need a voltmeter to work this out on a circuit. So you need to know the circuit symbol for a voltmeter and also how it's connected. An ammeter, which measures current, would be set in series, so in the same loop as the component that you're measuring. And this is different to a voltmeter. For a voltmeter, you must have the wires connecting either side of the component that you want to measure the potential difference of. If you try and think of it that you're measuring a difference, you kind of need to be measuring at two different points and measuring the potential difference between the two, which is the energy transferred by the charge. So how much energy is transferred across this lamp by the charge that's flowing through it, essentially. So that's why you have to connect a voltmeter in parallel to, so we say this is in parallel to the component, whereas an ammeter you put in series with the component in the same loop. So we'll get straight on to some questions now, which will ask us how to calculate potential difference, and if you're higher, they will also ask you about rearranging this equation and calculating work done or charge. So I've given you a couple of questions here. If you have a go at these, pause the video and then come back and see if you got them correct. So the first one then says calculate the potential difference when 50 joules of energy is transferred by 5 coulombs of charge. Now we need to annotate this with what we've been asked to calculate and what we've been given. We've been asked to calculate potential difference, which is V. We've been given energy transferred, and we look in our equation and think we don't have energy transferred here. So we look over here and we see work done, and we see that that is the same as energy transferred. So we know over here in our equation we've essentially got that W, and we've also got charge, which is Q. So we use that equation, V equals W divided by Q, and put our numbers in. So V equals 50 joules of work done divided by 5 coulombs of charge. So V equals 10 volts. Very well done if you got that one correct. Looking at the next one, when 5 coulombs of charge are moved between 2 points in a circuit, 20 joules of work are done. Calculate the potential difference. So again, we've been given Q, we've been given W, and we need to work out V. So V equals W divided by Q. So V equals 20 joules of work done divided by 5 coulombs of charge, which is 4 volts. So very well done if you got those correct. The next few questions will be a little bit trickier and will be mainly for the higher tier. So here are a couple of questions for the higher tier pupils to have a go at. You've got 2 equations that might be useful for you. Highlight the information that you've got and give these a good go. I'd pause the video and then come back and see if you get them right. So for the first question, it says calculate work done by a 9-volt battery when 50 coulombs of charge flows through it. So we've been asked to calculate work done, we've been given a potential difference, and we've been given a charge. So this time we need to rearrange the equation to make it W equals. So we multiplied both sides by Q, that will get rid of it there, and we'll put it on the other side. So V times Q equals W. So work done equals the voltage, or the potential difference, which is 9, multiplied by the charge, which is 50. So work done equals 9 times 50, which equals 450 joules. For the second question, you've got calculate the amount of energy supplied by a 9-volt battery when a 20 amp of current flows through it every 10 seconds. So here we've got energy, okay, which would be the same as work done, so I'm going to put that as W. We've got a 9-volt battery, which is our potential difference. We've got a current, which I know is the letter I, and time, which is T. And if you were to look at your data sheet, you wouldn't necessarily have an equation linking work done, current and time, or voltage, work done and current. So this is the case, especially in the higher tier, where you'd have to use 2 different equations. So I need to work out the amount of energy. So I need to work out work done. And if I rearrange this equation, I can work out work done. So work done, just like up here, equals voltage times charge. But I don't have charge. Can I work it out from what I've been given in the question? Yes, I can. Using this equation here, I can work out charge, because charge would be equal to current times by time. So if I do this bit over this hand side, I need to work out Q to be able to put it over here. So I've got Q equals I times T. All I've done there is taken this equation, multiplied both sides by T, and that will give me Q equals I times T. So then to work out the Q, I do 20 times 10, which is 200 coulombs. I can then put this 200 coulombs over here as the charge. So I would then have W equals my voltage, which in the question is 9 volts, times by 200 coulombs of charge. So my work done, or my energy transferred, is going to be 1800 joules. Okay, so bear in mind for these questions, you might have to use 2 different equations. So very well done if you got those correct. Thanks very much for watching. If you found it useful, then please press the like button below and feel free to subscribe.